All right, so we're going to work on solving trig equations. That's what this unit is. It's solving a whole bunch of trig equations, and today we're going to do it by factoring. So we practiced factoring a while back with a trig, and so now we're just going to add one other step. So it says find all x that satisfy the given equations from 0 to 2 pi for this trig equation. Now I'm going to do this one. Two different ways just to remind you of your goals with factoring. Remember, some people can do it without doing a substitution and some people do it with a substitution. But what I want you to see, I'll do it first without the substitution, is that notice I do have 0 on one side. When you factor, you have to make sure that you have 0 on one side. I'm going to look at this, and maybe you don't do a whole substitution, but what I want you to realize is that you're factoring like 2a squared minus 3a plus 1 equals 0. It just looks a little more complicated with the trig in there. So whatever method you use to do that, again, I'm a trial and error person because that's how I learned it. If you have an AC method where you go to grouping, I am great with that as well. So whatever it takes for you to factor that would be 2 sine of x and sine of x. Those are the only two options I have to multiply to get 2 sine squared. The only option I have to multiply to be 1 is 1 and 1. And then, of course, my signs are the same, and they're both negative, so I get that. Now, if I'm unsure about the factoring, remember, I could always in my head do a FOIL step where I check and go, okay, 2 sine squared, negative 2 sine of x, negative 1 sine of x, so that's negative 3 sine of x, and then plus 1. So I can always see that, yes, I am correct. Well, once I have it factored, then remember the whole goal then is if two things have to multiply to be 0, then either the first factor has to be 0 or the second factor has to be 0. And I'm going to solve those independently. So with this guy, I'm now at a single trig function. So I'm going to get down to sine of x is equal to 1/2. I think of the unit circle. I am in radians, notice. So I think where is sine 1/2? So that means y is 1/2. That would be here and here. So I would get the answers of x equals pi over 6 and 5 pi over 6. And then to solve this one on the right, I would get sine of x is equal to 1. And on the unit circle, that's of course up top here. And I would add to that pi over 2. So my three answers would be those. Now, again, I'm going to do this one. If you didn't see it with the trig, if you do a substitution step, and I never let it be x, I do a or u, or a is my favorite, I guess. I'm going to let a be sine of x. Again, notice that I'm factoring. If it helps you see it better, or you do your grouping, or whatever it is that you do, notice I would get the same factors. I would get 2a minus 1 is equal to 0, and a minus 1 is equal to 0. So a is 1/2, and a is 1. So in other words, sine of x has to be 1/2, or sine of x is equal to 1. And notice I'm right back where I was here, and I could get my answers. So if you like that substitution step, by all means do it, if it helps you see it a little bit better. And again, your factoring steps could look a little different. Let's look at number 2. What is a good first step on number 2? Well, I'll tell you a bad first step on number 2. This right here. No, don't do that. Because when you cancel out like that, you are canceling answers. Remember, you want to get everything on one side. So my first step is I'm going to bring everything to the left. So I'm going to do this, and Again, notice that I have 0 on one side. If you are factoring, get 0 on one side. Now, how do I factor? Is it ready to factor? Because we're going to eventually throughout the unit go, okay, do I need to use an identity? Well, the question you ask is, can I factor? If you can factor, then there's no need for an identity. Okay. Is there something you can factor? Well, yeah, there's something common. Cosine. So let's take that out. So if I take a cosine out, I'm left with 2 sine of x minus square root of 2 is equal to 0. And once again, I do the split. I have either cosine of x is equal to 0, or this thing is equal to 0. And you can skip a few steps if need be. Like you might go straight to this right here. Sine of x is square root 2 over 2. And when you have single trig functions, you're just going to the unit circle and using your little noggin. So cosine is 0. Where is cosine 0? Here and here. So this guy gives me pi over 2 and 3 pi over 2. And then where is sine square root 2 over 2? Again, sine is positive. Those are the pi over 4s. So I'm going to list the pi over 4s in quadrants 1 and 2. And I have 4 answers. So notice that in question 1, I had 3 answers. Question 2, I had 4 answers. And we'll see something even different in question 3. There's no way to look at a question from the beginning and go, oh, I'm going to have 3 answers on this question. You really don't know that until you go to the solve. So here's what I'd like. I'd like for you to stop the video and see if you can do number 3. See if you can do the factoring and get that one done and then come back. So do a little pause and come back to me. All right, let's see how you did. So if you are a substituter, I just want to make sure if you like the substitute, like this is what you're factoring. So you can kind of do it that way. If you don't need to do that and you go straight to the trig, you're going to have cosine and cosine. Factors that multiply to be 5, well, good news is you have one choice, 5 and 1, and needed to be plus and plus. Now, I'm even going to skip a step as well because I kind of, now that it's our third example, I'm like, okay, I'm going to set this equal to 0 and this equal to 0. I can kind of do that in my head. And I hope you're with me that I could get down to either cosine is equal to -1 or cosine is equal to -5. If you need to show setting it to 0 because that helps you, by all means do that. If you want to skip that step and get down to this statement, then that is, of course, fine as well. Now let's do the solving. Where is cosine -1? So cosine is x. X is -1 right there. So I get x equals pi. Now where is cosine -5? Cosine -5. So I'm, to do that one, yeah, I'm kind of in trouble because cosine can't ever be -5. So it's not that I did my factoring wrong. It's just that it didn't lead me to any answers. Remember right here, if you get down to sine and cosine, remember that sine and cosine both have to be between -1 and 1. So if you get a value outside of that, that doesn't lead to any answers, and you just have that wouldn't give you any answers. So again, you're not doing anything wrong. It just doesn't lead you anywhere. So again, notice in example 3 that I only have one answer, which I certainly couldn't have seen that from the beginning. So let's keep rolling. Hopefully you're like, okay, this isn't too bad. I'm going to do the factoring, which you should be pretty good at factoring. And then it comes down to the unit circle, hence why we give you those pop quizzes, because they have to still be in your little brains, right? All right, let's look at number 4. Let's look at the factoring on him. Is it ready to factor? Yeah, it is. It's ready to factor. I see a cotangent squared in both, so I will factor. and end up with this. And I'll tell you, there's more than one way to do this problem. Like some people, like literally you could see an identity here and change it. You certainly could do that. I'm not going to do it that way. But you could. My thing is, once you get it down to a single trig function, you can go to solve by isolating that trig function. So I'm going to keep it this way. Now, the next thing, just like we've done, either cotangent squared is equal to 0, or I will write this step, 1 minus cosine squared is equal to 0. So let's do one at a time here. This one you can think of a couple different ways. In order for cotangent, basically, if cotangent squared equals 0, then cotangent would have to be 0, right? So if cotangent needs to be 0, you can either think, well, cotangent is cosine over sine, so cosine would have to be 0. You can think of it that way. Some people go to tangent. Remember, the flip of 0 is undefined. So where is tangent undefined? So you get here and here. So I'm not sure which way you like better of figuring out that one, but hopefully one of those two ways resonates with you, whether you think, oh, cosine needs to be 0 or tangent needs to be undefined. So I get that. Now in this next one, if I solve, I would get cosine squared. I'd bring the 1 over, he'd be negative, but then this negative would cancel that out. So I get cosine squared is equal to 1. I wanted to do it this way because I wanted to remind you, when you get down in solving with a squared, you have to remember when I change it to cosine and I take the square root of this number, which doesn't look like I'm doing that, since the square root of 1 is 1, I have to put a plus and minus. Obviously, I didn't do that with 0, since plus and minus 0 is the same thing. But any other trig function, any other number, you would have to make sure you do the plus and minus. So where is cosine plus or minus 1? Well, I got here and here, so I need to add 0, pi, and 2 pi. Okay, now here's the thing. So I have 5 answers, right? That's pretty good. Now remember what a solve is, though. A solve is any value that makes the original statement true. That means theoretically in every single one of these problems, it'd be hard. It wouldn't be that hard, but I could go back and plug in pi and make sure that I got a true statement and it would check out. Well, let's plug in, for example, let's plug in pi. All right, so that means that the cotangent of pi squared minus the cotangent of pi, squared, boy, this is ugly, cosine of pi squared would need to equal 0. That would have to be, sorry, I kind of ran out of space. Well, what is the cotangent of pi? Well, the cotangent of pi, that's here. That's -1, 0. So cosine over sine, this would be undefined. Undefined squared minus undefined. Wait, that doesn't make sense. So what happens is, again, it's not that my work was incorrect, but these guys are not in the domain of cotangent, so I have to throw them out. So the only two answers I have are these two. Now you're going, oh, holy cow. So how am I going to check that? Why did I not mention that up here? Well, because look at what was in the original question, sine and cosine. We know the domain of sine and cosine is all reals. So that's why I didn't bother. But if I have anything with asymptotes, which is the other 4, I have to be careful. Now, I didn't want to mention it at the start of this problem, but some people like to do it at the beginning. And let's see what it comes down to. Hopefully you remember this. We'll stick with cotangent. Cotangent is cosine over sine, right? Cotangent of x is cosine over sine. It's going to be undefined when sine is 0. So cotangent is undefined here and here, meaning if you have cotangent in a problem, you cannot list those as answers. 0 pi and 2 pi cannot be answers. What other trig function would that be true for? Think, what else has sine in the denominator? Hopefully you said cosecant. So if you have cotangent or cosecant in the problem, you have to eliminate those two. What about tangent and secant? What do tangent and secant have in their denominator? Cosine, right? They have cosine. Well, if cosine is in the bottom, that means that these two are going to be undefined when cosine is 0. That's here and here. So I would have to eliminate those. Now, how you do these problems is up to you. There are some people from the get-go, for example, in number 5, I see cosecant and I do it first. I go, hey, it has cosecant, so I am going to throw out this and this. I know if I get that for an answer, I have to throw it out. Other people say, I'm not going to do it from the beginning. It's only the quadrantals I have to worry about. I'm going to see what my answers are, and then if they are quadrantals, I'm going to make sure that I don't need to throw them out. I don't care which one you do. You just need to make sure you think of it. Okay, whether you do it at the front end or the back end, that's up to you. You just can't forget. So let's finish out number 5. Number 5, is it ready to factor? Yes, it is. I'm going to pull a cosecant out. I would have cosecant plus 2 is equal to 0. That would give me cosecant is either 0 or cosecant is either -2. Now, anytime I get down to the reciprocal functions, cosecant or secant, I don't know those all that well, so I change them to sine. I'm going to start with this one. If the cosecant of an angle is -2, then the sine of the angle is going to be -1/2. So that is going to give me answers here and here. So I get 7 pi over 6 and 11 pi over 6. And then is cosecant ever 0? Some people might remember the graph. Or you just say that would be where sine, remember the flip of 0 is undefined. Is there a place where sine is undefined? Nope, that doesn't lead me anywhere. So I would have these two answers. Do I have to worry about throwing them out? No, because they're not quadrantal. So again, that's why some people go, hey, I'll look to see what I get and see if I need to throw them out. But that is solving by trig. Key things, make sure you have 0 on one side before you factor. Do your factoring, isolate the trig function, and go to the unit circle. All right. Peace out.